We've all been there, right? In that big meeting, decision time, and someone has to admit, well, the sales data is 3 hours old. Or maybe we don't get the real inventory numbers till tonight's batch run.
Mm-hmm. That lag used to be just, well, annoying.
Yeah, but now it feels like a real competitive disadvantage. The sources we've gathered for you really hammer this home, relying on data that's hours, even days old. It's just obsolete.
It really is. It's become the defining bottleneck for so many modern businesses. And that's exactly why our source material for this deep dive focuses so heavily on defining and implementing real-time master data management, MDM.
Right, MDM.
It's really not an optional extra anymore. The research we looked at positions it as, well, the absolute cornerstone of any modern data setup.
Yeah.
It's about shifting critical business knowledge from those scheduled archive reports
Into something happening right now.
Yeah.
Instant operational intelligence.
Precisely. So our mission today is basically to break down this pretty complex technical shift. If you're, say, a data manager trying to make the case for investment, or an IT architect designing the new pipelines, or maybe a BI lead just needing fresher insight.
Then yeah, you need to quickly get your head around this move from classic batch processing to continuous data synchronization. It's a big one.
Let's start with a clear definition, though, because real-time can mean different things to different people. Real-time MDM, based on the sources, is the practice of continuously synchronizing, validating, and distributing trusted master data.
And master data, that's the core stuff, right? Customer IDs, product codes, supplier details.
Exactly, the foundational data. And continuously means with minimal latency. We're genuinely talking seconds or even milliseconds for updates to ripple across the whole enterprise.
Wow. Seconds. That kind of instant consistency is pretty powerful. It means every system from the website the customer sees to the internal finance ledger, they're all working off the same up-to-the-second information.
It changes the game. So the difference between real-time and batch MDM, it's not just about how fast it is. It's a fundamentally different architectural philosophy.
We all kind of know batch MDM, right? It's the familiar workhorse, scheduled updates, hourly, maybe overnight.
Predictable.
Predictable, yeah. Latency is measured in, well, hours usually.
Yeah.
And the architecture behind it relies on those heavy file transfers, big ETL jobs, extract, transform, load.
Often quite brittle, too. Those jobs can break easily.
True, but it's fine for things like end-of-quarter reports or digging through historical archives for compliance.
Exactly. But real-time MDM,
Yeah.
it just throws that whole model out the window. It operates more like a publish-subscribe system. Updates are continuous, pretty much instant.
So latency is near zero.
Near zero, yeah.
Yeah.
And you ditch the file transfers for things like event streaming, lightweight APIs, message queues. It's a different world.
And the focus shifts too, right? Not historical reporting, but live operational systems.
Absolutely. Live personalization engines on websites, instant credit decisions, real-time AI trying to figure things out. That's where it shines.
Yeah, okay, let's push on that a bit. If we can run a batch job every hour, I mean, isn't that often good enough? What's the real cost of waiting that hour?
That's a fair question. The sources really highlight that modern analytics platforms, and especially machine learning models, they're essentially starved by batch processing.
Starved? How so?
Well, they need fresh, accurate data to do complex stuff, like
Yeah.
predicting when a machine might fail or spotting some new kind of fraud pattern as it emerges. If your model is running on data from yesterday or even an hour ago,
A prediction could be wrong. Or just useless.
exactly, or worse, misleading.
Okay, so if I'm running, say, a product recommendation engine on my website and a customer updates their preferences 5 minutes ago, that engine needs to know right now. Otherwise, I might show them stuff they just told me they don't want, which is just annoying.
Precisely. Or think about a higher stakes example, like fraud detection in banking. An AI is looking at a large, maybe unusual transaction.
Yeah.
It needs instant access to the customer's very latest behavior patterns, their current security settings, their up-to-the-minute risk score, if that data is even an hour old.
That could be the difference between stopping a fraudulent transfer and losing a lot of money.
Exactly. Millions,
Yeah.
potentially. Real-time MDM ensures that decision-making engine, whether it's AI or a human rule, reflects the absolute current state of the business, not yesterday's picture. And when you manage to kill that latency, the business benefits aren't just small improvements. The sources describe them as genuinely transformative.
Okay, like what?
Well, the first one's pretty obvious.
Yeah.
You enable confident, instant decision-making everywhere. Sales teams can pitch knowing the absolute latest service history for a client.
Or supply chain managers can see inventory issues the second they happen, not hours later.
Right, that kind of speed.
Mm-hmm.
But the source material also puts a really strong emphasis on enhanced customer experience, or CX. We hear that acronym a lot.
Yeah, CX. What's the specific, measurable benefit there that old-style MDM couldn't deliver?
It really boils down to trust and consistency. The research we looked at shows that when a customer updates their info, maybe a new address or changing their contact preferences,
Uh-huh.
they just expect that change to show up instantly, everywhere. On the mobile app, when they call the contact center, in the next marketing email they get.
And if it doesn't?
If there's a lag, it creates friction, it makes the company look disjointed, it erodes that customer's confidence. Real-time MDM delivers that seamless consistency they expect.
Okay, that makes sense. Now, what about the classic data headache, bad data? We traditionally spend so much time cleaning up messes, often days after the bad data got in and, corrupted everything downstream.
Ah, yes. That's where the proactive data quality management aspect of real-time MDM comes in. And this is a massive shift from the old reactive cleanup cycles.
Proactive how?
Instead of waiting for some nightly batch job to fail and flag an error, real-time MDM applies validation rules, standardization logic, all those data quality checks the moment data tries to enter the system.
Ah, so it stops the bad data at the door before it can spread and cause problems in the data warehouse or the analytics tools.
Exactly. You prevent the contamination in the first place.
That must save a huge amount of time and money.
Absolutely. There was one compelling insight from the sources. It noted that catching and fixing these issues instantly cuts all that downstream cleanup and troubleshooting work. A time data scientists spend just cleaning data instead of analyzing it by an average of something like 40%.
Wow, 40%, that's huge.
It is. You eliminate the data pollution that just cripples analytics platforms.
Yeah.
And finally, this continuous stream, it bridges that gap we always had between the fast transactional systems where things happen and the slightly slower analytical systems where we try to understand what happened.
Right. It gets rid of those blind spots caused by batch delays. Everyone's looking at the same current reality. System alignment, basically.
Okay, let's dig into the architecture then. Delivering that kind of instant consistency. It sounds like it needs a completely different set of technical plumbing compared to batch. What are the key components our IT architects listening need to think about?
Yeah, the foundation is really event-driven integration. You just can't get real-time speed by constantly hitting databases with queries asking anything new, anything new. It doesn't scale.
So what's the alternative?
Instead, you use platforms like Apache Kafka or maybe Azure Event Hubs or Google PubSub. These become the data backbone. When a record changes in the MDM system, say a customer updates their address, the MDM system publishes a single event.
Like a little notification.
Exactly, a notification onto this central stream. And then any downstream system that cares about customer addresses the CRM, the billing system, the marketing tool, they subscribe to that stream and consume the update almost instantly. Okay, that decouples the systems nicely, but that sounds incredibly complex to keep running 24/7. What if a receiving system is down for maintenance? Or what if it takes a bit longer to process the change? How do you guarantee consistency? Make sure the update is processed exactly once, even with network glitches or system failures, all within milliseconds.
Yeah, that is the architect's real headache. The sources definitely stress the need for things like idempotent consumers.
Idempotent meaning?
Meaning systems that can safely receive the same event message multiple times without messing things up like creating duplicate records.
Yeah.
And you also need sophisticated reconciliation logic, often built right into the MDM hub itself, to track message delivery and ensure that consistency you're asking about, even when parts of the distributed system inevitably fail or lag behind.
Okay, so specialized tooling is key there. And what about organizations dealing with, those huge old legacy systems, the ones you can't just switch off overnight?
Right. That's where something called change data capture, or CDC, becomes really valuable. Yeah. Change data capture. These tools basically monitor the transaction logs of the source databases directly. They watch for changes as they happen without you having to modify the old legacy system itself, and then they stream those changes out.
So it's a way to tap into legacy systems non-invasively.
Exactly. It's fantastic for enabling that kind of incremental modernization,
Mm-hmm.
but architects need to be ready for the complexity of managing schema drift.
Schema drift, like when someone changes a table structure in the source system?
Precisely. The CDC pipeline and everything downstream needs to be able to handle that change gracefully without just breaking instantly. It needs careful design.
That sounds like a really practical pro tip from the sources. Now, thinking about implementation strategy, you can't just flip a switch and make everything real time at once, can you?
Oh, absolutely not. Trying to boil the ocean, as they say, is probably the single biggest mistake highlighted in the research we reviewed.
So what's the advice?
Start small. Be surgical. Pick one or two really high-value master data domains, usually it's customer data or maybe product data, and focus on getting real-time working there first.
Prove the value in a manageable scope.
Exactly. It reduces the initial complexity, lets the teams build up that specialized expertise with streaming tech, and crucially, it demonstrates the ROI quickly, which helps justify further investment.
Okay, let's make this more concrete with some industry examples the sources mentioned. In retail, they talked about unified commerce being impossible without this.
Oh, totally. Real-time MDM is what lets retailers merge, your online browsing history, your in-store purchases, your mobile app activity, all instantly into that single unified customer profile everyone wants.
And inventory.
Critically, yes.
Yeah.
It synchronizes inventory levels between the physical warehouse shelves, the point-of-sale system at the checkout, and the e-commerce website. That stops that awful, oops, we sold you something we don't actually have experience.
Yeah, we've all been there. Overselling destroys loyalty instantly.
Right. Then in financial services, the sources emphasize speed equals security.
And efficiency too, presumably.
And efficiency, absolutely. Real-time MDM isn't just powering that instant fraud detection by checking current risk scores against live transactions. It's also dramatically speeding up customer onboarding.
How so?
Instead of all those manual checks and slow batch validations that used to take days,
Right.
real-time MDM can validate identity documents, check against AML, anti-money laundering lists, pull credit scores all in minutes. It completely changes that initial customer journey.
Okay, impressive. And finally, manufacturing. Big focus there on quality and supply chain.
Yeah, real-time synchronization is vital for quality control. If a component specification changes or a supplier updates their terms, that info needs to flow immediately to production planning systems and the QA teams on the factory floor.
Makes sense.
And it also enables things like predictive maintenance. You can combine the real-time master data about a piece of equipment, like its serial number, its maintenance history, with live sensor data coming off the machine itself.
Connecting the static master data with the dynamic operational data in real time.
Exactly, to predict failures before they happen.
Okay, the vision is compelling, definitely transformative. But let's get real for a moment. The research also warned about some pretty significant implementation challenges. Setting up and running a 247 continuous stream, that must involve some hefty infrastructure costs, right?
It certainly does.
Yeah.
Real-time MDM needs infrastructure that's always on, highly available message queues, high-performance databases. It's not cheap. Cloud platforms offer elasticity, which helps manage the scaling cost, but yeah, there's a baseline cost.
And complexity.
Honestly, the architectural complexity is often the more persistent challenge than the raw cost. Making sure those continuous data flows work reliably, handling errors in the stream gracefully, maintaining that strict consistency across maybe dozens of distributed services. It requires constant, sophisticated monitoring and expertise.
That operational complexity points directly to another challenge mentioned: skill gaps. Your traditional database admin or BI analyst, they might not have the skills needed for this kind of event-driven streaming architecture.
That's a really key finding from the sources, yeah. Data engineering teams need specialized skills in things like fault tolerance design, specific stream processing frameworks, Kafka streams, Flink, Spark streaming, and just general event-driven architecture patterns. Organizations have to be ready to invest seriously in training their people or bring in specialized external partners.
Okay, so infrastructure, complexity, skills. What about security and governance? If data is constantly flowing everywhere and near real time, our traditional security models, like locking down the database perimeter, don't seem sufficient anymore. How do the sources advise balancing that need for speed with absolute non-negotiable security?
That's really the crux of governance in this new world. Security has to shift from the perimeter to the data stream itself. Architects need to implement things like fine-grained role-based access control, RBAC, but applied specifically at the data attribute level within the stream.
So controlling who gets to see which specific piece of data as it flows.
Exactly. Determining which specific downstream application or microservice is allowed to access, say, the customer's phone number versus just their masked ID, all based on policy applied in real time.
And for really sensitive data, PII, PHI, that kind of thing, how do you protect it dynamically without adding latency that kills the whole point of real time?
Modern real-time MDM platforms are being built to handle this. They could apply dynamic data masking, or maybe tokenization, or even field-level encryption automatically as the data flows through the stream.
Ah, so the security transformation happens in flight.
In flight, exactly. This means, for instance, the sales team CRM might receive the customer record, but with the credit card number masked, while the secure billing system gets the fully unmasked record, all governed by centrally managed policies, without slowing things down noticeably. Now, looking ahead, the evolution here is speeding up, largely driven by automation and AI. We're starting to see the rise of what the sources called AI-driven data quality.
AI managing data quality, how?
Well, think machine learning models that learn what normal data patterns look like for your business. They can then automatically detect anomalies or outliers in the real-time stream, maybe suggest corrections, and potentially down the line, even auto-remediate certain types of data quality issues without needing a human to intervene.
Wow, like self-healing data systems.
Kind of, yeah. That's the vision emerging.
We're also hearing a lot about the data fabric concept.
Here.
How does real-time MDM fit into that broader picture?
It's seen as a core foundational component. In a data fabric architecture where your data might live across various hybrid clouds, on-premise systems, data lakes, warehouses, it's distributed everywhere.
Right.
Real-time MDM acts as that central, consistent definition layer. It ensures that no matter where the data physically sits, the meaning of customer or product or supplier is unified, consistent, and immediately accessible to any application or user needing it. It provides that essential semantic consistency across the distributed landscape.
Okay, so it's the truth layer within the fabric.
Precisely. And pushing the boundaries even further, some sources talk about the future involving agentic data systems.
Agentic, like autonomous agents.
Yeah, essentially autonomous software agents that could manage data flows, automatically resolve data conflicts based on predefined rules, optimize streaming performance, and even enforce governance policies with minimal human oversight.
That paints a picture of operations becoming incredibly intelligent, almost self-managing, and super responsive.
It's definitely heading in that direction. Very dynamic. Hashtag tag outro. So to kind of pull all this together, the clear message from the sources is that real-time MDM, it isn't some far-off future technology. It's really a fundamental shift that's needed today if organizations want to stay competitive, truly get value from AI and machine learning, and basically build a foundation for a faster, smarter analytics ecosystem.
Yeah, and the pathway to actually getting there, it seems, requires really careful surgical planning. The big takeaway for me from our sources was focus on those high-value use cases first. Customer data, product data, prove the benefit there. Don't try to make everything real-time from day one.
Absolutely. Scale incrementally, show the business value, build expertise, and only then expand the architecture. That seems to be the recipe for success.
And we also stress throughout that the speed, this real-time capability, it absolutely cannot come at the expense of proper governance and compliance.
No, definitely not. In fact, real-time MDM actually requires incredibly robust logging. Every access, every modification event needs to be tracked in near real time to maintain those strict audit trails you need for regulations like GDPR, CCPA, IPA, and so on.
Okay, so here's our final thought for you, the listener, to maybe mull over, building on that point. Real-time MDM demands systems that operate in sub-second timeframes. But that essential compliance piece requires continuous, high-volume, real-time auditing and logging of everything happening to the data.
That's a challenge.
So the question to consider is, how will your organization design and manage this incredibly demanding real-time auditing requirement without that very compliance process itself introducing performance latency back into the high-speed operational systems it's supposed to be governing and protecting? It really feels like the ultimate tightrope walk between